All right, so I started recording, and let me answer some messages in a meeting chat. So Kevin asked, when turning in the network tools assignments, can we turn a zip file with everything in it? Yes, Kevin, you could do that, right? So you can do it. It can be a zip file or it can be a tar, a compressed file. So it can be a tar.gz. So either or, it doesn't matter. So whatever you want to do, either of the two will work perfectly fine. All right. So what we're going to do today, we're going to cover cryptography. And I actually have this presentation already recorded. However, we're going to cover it. And then in class, we are going to go over the assignment for cryptography. It's quite a bit of stuff. And then there's going to be some stuff that we will need to do probably on the weekend. Just because if you do it at the university, they may block what you're trying to do in search. So we'll do it at home over the weekend. For individuals that need to do the graduate research paper or any research paper in general, I did create a presentation. It's loaded on YouTube. I posted it, I believe, I think it was maybe yesterday. Should have been yesterday, last night, or even this. Yeah, it should have been last night. And so it's just a weekend lab, and it covers how to effectively write your research papers or your papers in general, collect information, um, where you can gather data from and stuff like that. There's going to be an assignment called dealing with data. And with that particular assignment, what you'll do is you'll actually grab data from sources and you'll have to find repositories. On the research paper, I talked about where to actually find that open access data, to pull that information. And then we'll talk about later how to analyze it. We'll go over some various some tools that will, I think, work fairly well. And we'll do that to make sure that you're able to, I guess, get the full experience and make full use of what you have, right? So, any questions so far about what you've learned or anything that you'd like to discuss? Right? I just want to have the floor open. So if you have any questions, feel free to ask questions. And it doesn't have to be related exactly to what we talked about. Maybe it could be just, the course. It could be something that deals with like internships, any question that you like to talk about or want me to address so I can make a note to make sure I have that for you in the near future. All right, with that said, is there anything that you would like to talk about or address in the future? There'll be some dates that we have the ability to have discussion on these items. And so if you would like to, I can make time to have these items discussed. So that's something else that can be done as well. Sure. So Kevin, the final, as of now, I have the project. So there's going to be a couple things. So the project is going to count a lot towards your grade. There's going to be a group project is going to count towards a lot. The final exam is going to be one that you can do online, and I will actually provide that exam. It will be open the first week of December because I understand that you guys have a lot of exams and stuff like that, and it's going to be a lot in general with this particular group project. And so the final exam will be open. You won't know the grade of the exam until after everyone's taken an exam, and then you will know. But it'll be delivered via here, and it will be questions that come directly from the books that are attached. So it's open book, open note. It is timed, and so you'll have a number of questions. Now, it's come from a question pool, and so with that question pool, even if you're sitting next to somebody, they will have different questions, and it'll be timed, right? So see if you have 50 questions, maybe 55 minutes. You may have something like that. They'll be randomized and of that particular nature. And then you'll get the results once you are done with everything, right? Well, not once you're done, once we're all done with everything. So it'll work like that. But I will give you a study guide, but the study guide will directly come out the CISSP CBK, right? There'll be those questions. So think of it as I guess a look ahead if you're going to take like Security Plus or attempt to take the CISSP, which is the Certified Information Security Professional. All right, Mohammed says, for the current networking assignment, Are we presenting that in class, or are you just going to grade it normally? So for the networking assignment, you are going to, you can have everything recorded and then upload that particular presentation, and then it can be viewed that way by myself and the TA. Now there will be, now when we do the penetration, we'll make sure that one is done live in class. So you will do that one live in class, but the other one we'll just do it like that.
Harry Potter.
All right, so we got 2 questions. Any other questions before we start the lecture? No, there's not a midterm, Naga, but do you want a midterm? Because I have one ready if you would like a midterm. But I figured since with the significant amount of assignments to do and the independent reading you should be doing outside the class, the midterm was a bit too much. So I just figured like I would just try to make it I guess realistic, even though when I look at it, it doesn't seem realistic, but I just try to make it realistic so you guys can, you know, be able to tackle this. I know some of you guys have like 4 or 5 of the class at the same time. I hear you, Kat. All right. So we're going to talk about cryptography, right? So when we say cryptography, a lot of things come to mind, right? We think about like secret messages, think about the Freemasons, being able to see these messages like in plain sight, but all encoded. So what we're going to do is we're going to talk about cryptography, sort of the beginnings, what is it? And then in class this week, we're actually going to do some pretty cool cryptographic items, applications. So, and then this weekend, we'll do more cryptographic items where we explore Tor, the dark web, and stuff like that. Again, no buying drugs, we're on there. Just don't do it during class, and don't say you learned something from me. Seriously, but we will see some pretty cool things, because even Illinois Tech has a page on the dark web, and that page talks about the underground tunnels here, where you can walk from one building to the next underground. So I'll show all that cool stuff. All right, so this particular domain discusses the principles, means, and methods of applying mathematical algorithms and data transformations to information to ensure its integrity, confidentiality, and authentication. Right, you'll notice here it doesn't say that cryptography is for availability. Why? Because when you add cryptography to anything, it is going to take a longer amount of time for the particular item to be transmitted, for it to be unencrypted. It adds, I guess you could say, weight to that particular item, and it's going to add time for decryption and encryption. Now, for one of my particular devices, I have the home drive encrypted, I have my desktop encrypted, and I have other encryption applications added. What that means, with my solid state drive running like Ubuntu, maybe it takes no more than like, I don't know, 15 seconds from power on to actually getting into the actual desktop, right? It's fairly quick. However, when adding an encryption, especially to like a terabyte hard drive, it takes a long time because everything has to be decrypted. I finally get into the Ubuntu desktop, then my home folder's encrypted, so now I got to unencrypt that. And then if I'm using other applications such as Firebird, and I'm encrypting messages, I got to think about that. I have to share keys. I mean, it's a lot of time that it takes to use the application in its entirety, right? So availability is not one of those things. You can't say, all right, I'm going to add encryption, and I'm going to make sure that this app is available. No, it doesn't do that. Confidentiality, make sure that it is kept safe, that no one can see it. When you're reading something that's just plain text, it's plain text, right? It's just open and declare. Anyone can see it, but when you're trying to scramble that, when you're scrambling it, then that's a ciphertext. And it takes a while to go from ciphertext, plain text, ciphertext, back to plain text, and vice versa. It takes a bit. All right. These are just, when I mentioned the objectives of cryptography. What does it provide? Cryptography provides encryption, right? It provides encryption. Not anyone can view those messages they can't view the text, they can't view any of that stuff because it's encrypted, right? So integrity, hash, message, digest, authentication, or repudiation. You can't say that you didn't send it. It's like, well, you can't send it. I can see it right here. So non-repudiation and authentication, you can verify the identity of the subject. So I send Kat a message, right? And then Kat's like, Dr. Mog, I got your message. Like, oh no, Kat, that's not for me. Kat can say, look, buddy, I can see that you signed the message. This is from you, right? So Kat can immediately tell me like it's from you. Here's your signature. You know, either you sent it or someone has physically access to your account, your machine or your account, and they're sending on your behalf, but they have access to your key as well. All right, so cryptography is the secret of science writing. Sorry, the science of secret writing. Cryptology is the study of. Sorry.
The screen isn't sharing.
No, what did you say? Was that Alex?
No, that's me, Kevin. Your screen isn't being shared.
Oh. Okay, you should see my presentation. You don't see it?
No, it's not. It's not there.
All right, let me do a new screen capture then. All right, is it sharing now?
Yep.
Okay, awesome. Okay. All right, so cryptography is the science of secret writing. Cryptology is the study of cryptography and cryptanalysis. The crypto system is a hardware and software implementation of cryptography. What's interesting, there's type 1 through type 4 cryptography. Type 1 is NSA approved hardware, software. Type 2 is, well, type 1 is only for classified systems. Type 2, unclassified. Type 3 is just the software. It's the FIPS, Federal Information Processing Standard. And type 4 is like something you just make up on your own, right? And then get some type of level of approval. The algorithm is the precise rule or set of rules specifying how to solve some problem or accomplish a specific task. Then you have the cipher. This is the cryptographic transformation operating in bits or characters. Plain text or clear text is what I talked about earlier. This is just if I write a message and it says, hi, my name's Joe, you know, and it's just nothing's done to it. That's plain text, right? You can see exactly what the message is. It's unscrambled, is in its natural form. Now, ciphertext or the cryptogram, this is the scrambled data. You look at a message like, I have no clue what this says. What is this? It's like gibberish, not even gibberish, because it's random, you know, stuff that's moved around. To encipher, encrypt, or encode is the act of scrambling using a key. And then decipher is descrambling with a key. This Thursday, we will create keys ourselves, and then I will talk to you guys about key management. Key management is extremely important because you don't want to have keys existing out there for years, right? You want to say, I want to have a key. It's going to maybe exist for 3 months, no more than a year. This is how I'm going to manage the keys. This is the level of encryption I'm going to have in the keys. All that is extremely important. Cryptanalysis is the practice of breaking crypto systems and obtaining plain text or obtaining plain text from the cipher text without a key. And then the work factor is the time, effort, and resources necessary to break a crypto system. The key, a secret value in the form of a sequence of characters used to encrypt and decrypt. When we send messages back and forth, we are going to share our public keys, right? We're going to share our public keys to individuals when we send the messages back and forth. Key clustering is where two keys generate the same ciphertext from the same plaintext. And then key space is all possible values used to construct keys. The larger the key space, the better. And then initialization vector In crypto, the IV is a block of bits used as the initializing input algorithm for the encryption of a plaintext block sequence. So here's the history of cryptography. 1500 BC, you have a Mesopotamian tablet. It contains an cipher formula for making of glazes for pottery. Now, 47 BC, the Greek uses a skytail. It was a staff that they would take a long strip of leather, and it would have the message on it. So you could only read the message if you had the staff, right? So you would walk around with the leather strip, and no one knows what it is, right? Just a strip. It's, it's long. It has random characters. However, when you put it on a staff of the particular diameter, you could read it. You go, okay, now I see what the message is. Then in 50-60 BC, Julius Cipher used a simple substitution with the normal alphabet, and basically you're just shifting the letters a fixed amount. That's all it is, right? You're just shifting letters. So A would be C, B would be D, and it would just work like that. You're just shifting letters. 1790, Thomas Jefferson invented the Will cipher, and the order of the disk is the key. So if you knew the order of the disk, then that was the key. In 1854, Charles Babbage reinvented the Will cipher, and you can see below here is the Will cipher that Charles Babbage reinvented. 1919 and 1922, patents were issued to Gilbert Vernem for the Vernem cipher. And then preceding that, you start having the wars, right? Our world wars. 1930 to 41, the German military used the Lorentz S740 and the S742 cipher machine that was based on the Vernem cipher to encrypt teleprinter messages. And then 33 to 45, the German military field units used Enigma cipher machine to encrypt messages. And now there's actually a movie about the next event, but you have, okay. And then 43 to 44, British code breakers designed the Colossus Mark I and Colossus Mark II to decrypt the Lorentz cipher machine. And then 38 to 44, British code breakers designed Bombay to decrypt the Enigma cipher machine. Right, that is what you had afterwards. And this was designed by Alex Turing. And there's a movie about this gentleman, and it's called The Imitation Game. Right, The Imitation Game, it is a great movie. I would suggest you watch it if you have nothing going on this weekend and you really want to kill some time and be productive, right? I would advise watching The Imitation Game. Kat, I'm glad that you love Alan Turing. What's interesting, the way that he recruited individuals for this particular mission, he put out a newspaper. If you can decrypt this or solve this puzzle, please come in. And people who were solving the puzzle came in. The key thing that you have to realize is that the British intelligence agency was working with him, and when they could finally decrypt messages, they didn't act on every decrypted message that they got. Why do you think they did this?
I mean, if they acted on every message, then the Germans would know that their code was broken. So if you only act on some of them, that gives them plausible deniability for, having not broken it, and just like things being compromised by chance or by conventional means.
Yes, because there's like, wait a minute, these guys know everything that's going on. They need to now switch the algorithm. And so now they have to go break that. And Mohammed, you're correct as well. Yeah, so now they have to break that. So they had to say, all right, well, we're going to have a few casualties. We're going to think about what is greater to know their strategic positioning, or to try to save everything at once. You have to be very strategic. You have your long-term strategy, and you also have tactical stuff, but they were thinking more strategic, and that was what I felt was really good about this movie. It showed kind of when they had a discussion, they showed they talked about the importance of that. In 76, the NSA chosen IBM's modified Lucid cipher to be the standard for data encryption standard, which is DES. Later, you have triple DES. 76, you have Diffie and Hillman. They published a new direction to cryptography. 2 years later, you have published the RSA algorithm for public key system. 6 years later, you have the ROT3 cipher that was introduced in the Unix systems, and it encrypts clear text messages by shifting letters 13 spaces. 91, you have Zimmerman, who released the first version of Pretty Good Privacy. In this class, we were going to use GNU PG, which is GNU, not Unix, Pretty Good Privacy. Yeah. We're going to use the open source version. Now, PGP, the last time I checked, it was several $100s for an 8-year license. Extremely expensive. GNU PG is open source. Anyone can use it. You can do some really cool things with it with GNU PG. 2000, you have AES, which is the advanced encryption standard. So that was selected by NIST. So here it talks about cryptographic algorithm. You can see it's a set of mathematical function and rules that take plain text and a key as input and the product ciphertext as output. So encryption, you're encrypting plain text into ciphertext, or you're converting plain text into ciphertext, and decryption is just the opposite, right? You're taking the ciphertext and you're putting it back to plain text. So here it shows the key. You can see the message sender, you can see the message. They have a little formula here. It goes to a crypto system, it gets encrypted, it becomes ciphertext. It's sent, right? It's still in ciphertext. And the recipient uses that secret key, shared secret key, and it goes to their crypto system with the key applied. And then they can see the plain text. When we actually do this, you'll see that it is a lot. It's not complicated at all when you're going through the actual converting, plain text, ciphertext, and vice versa. It's not complicated. The process is just setting everything up. Once we set up the entire system, then we're good to go. All right. So the goal of the crypto system is to make it too expensive and too time consuming to justify the effort. That's the goal. That is why you have all of these particular, I guess you could say, cryptographic components, right? So individuals or nefarious actors, they have to think about, okay, well, how much time or money do I want to expend to break this system, to get access? Right? So if they're going to spend, months and months to break something, whereas what they get out of it, it's not really worth their time, they'll say, okay, we're gonna move on to something else. Right? That is the goal. Not saying that someone can't break the crypto system, but it's to make it too expensive and time consuming. It's like robbing a bank. Hopefully nobody here wants to rob a bank, but you're looking at banks, you're like, okay, well, what is the easiest bank to break into? You're not going to look for the most difficult bank to break into, right? It's like, can I do that? No. Right? You're looking into something that you can justify the effort, right? You need to be a justified effort if you're a nefarious actor. All right, the strength of the encryption comes from the algorithm, the secrecy of the key, length of the key, initialization vector, and then how they all work together. That is the strength of the encryption method. All right, so these are classic ciphers. We'll talk about classic and modern ciphers, but classic ciphers, substitution, transposition, polyalphabetic, and then concealment. And then modern ciphers, block, stream, steganography, and combination. Cool thing that we're going to do, we are going to do an example of steganography in class. So we'll create a message, put it in an image, and we'll send it out. I'll show an example of how some sites will actually strip the metadata, And I'll show how you can get around that and how you can send a message, have it tagged, have people actually post a message, and it will still have the metadata and the actual message in there so you can later, you know, retrieve that message. All right, substitution. All this cipher does is just substitutes one information for another. All right, so shift alphabet. Remember shifting, earlier talked about shifting places. That's all it does, it just shifts, right? So here it just shows that sliding everything up by 3, and that's what they're doing for the message. The problem is, this is actually something very easy to figure out, but perhaps in those days, not so easy. But all you're doing is shifting the alphabet. Running key. So running key is a type of substitution cipher. And this particular item is the secret key is repeated along the length of the plain text. So you look at the plain text below, computing gives insight, the keyword lucky. And so from that, you can see the actual ciphertext that was created from the plain text. Transposition cipher. So instead of replacing the characters with other characters, this just changes the orders of the character. And so the key determines the positions of the character. Sorry, the key determines the position that the characters are moved to. And then the key for that cipher is not standard. So instead of alphabetic substitutions, it is a mapping order. So here it shows 1, 2, 3, 4, 5 equals 3, 4, 5, 2, 1, meaning that the third element is put in place of the first, thus followed by the fourth and the fifth, second, and finally followed by the original element. So you can see the example of world. You can see 1. So it shows 1 is all the way to the back. All right. So 1 moves to the end, 2 moves, fourth, the third one becomes the first, the fourth becomes the second, and then the fifth becomes the first. Now, with this, if the items aren't like in a block, it is easy to figure something out because there's just some words that are just single letter, right? I, A, then you have these 2-letter words, he, B, what else is there? If, is, you know, so shifting those particular letters around those is not going to work. It doesn't work at all. And then once you figure out how something's been shifted, then it's rather easy to figure out the larger words. Now, the reason I know this, as a kid, I used to get cereal boxes when we lived in Germany. I think it was Trix. And they would always have like encoded messages, and you could always win something. You could figure it out, cut out the box. I did this, you know, I think hundreds of times. I never got anything back. Maybe it was a scam. So I used to do these messages all the time in hopes of winning. So they had transition, they had all types of different types of keys that you could solve on the cereal boxes. All right. This is what I mentioned earlier. I was referring to permutations. So it just says, sorry, transition. So permutations of the cipher run in block messages. And I said that is key because if items are singled out or there are a certain number of characters, you can begin to figure out the words. Not even using like a dictionary, you can just move particular letters around and figure out what the words are. So here it just says, example is I love CIS CBK review class 2012. And you can see that the way it's broken up is just in a block matrix. Yep, so everything's 7. So every 7 characters, new line, new word, right? New characters. I love, but the problem is you can still go into something like this and figure out what it is, because even though they're blocked, you can say, all right, well, I know that you can take vowels and say, all right, well, I know A's here, I's here, A's here. I'm going to try to pull these apart and then figure out what's in between. All right, concealment cipher. This cipher is a lot better. This hides a message within a longer message. And so it just says a paragraph is sent to you containing an embedded secret message. Example is the agreed upon secret key is every sixth word. Selecting every sixth word in the paragraph decrypts the actual message. I have been trying to buy you a nice gift like gold or an antique, but prices now are really high. So every sixth word is buy gold now. So this is hiding the message in plain sight, right? You're reading pages to a book and you're like, okay, interesting. But individuals saying, hey, every sixth character, or these are the words that make up the actual rote message. So it doesn't have to be every sixth word. Someone can say, all right, well, this is the actual key, right? So the secret key is 6532 or something like that, and then go to page so-and-so, and you go to that page, you look at that particular key, and you get the actual real message. There's a couple of movies and one fraternity that's well known for doing this through the movies is the Freemasons, known for having concealment ciphers and in particular books and stuff like that. Again, another good movie with the Freemasons. That there's a couple of them that are out there, but I'll provide you one that you may want to watch as they talk about concealing stuff pretty much in plain sight, and that would be the Da Vinci Code. So yeah, so Imitation Game, Da Vinci Code, it's on Amazon Prime. Looking at it right now. This, these are good movies to watch. All right, block cipher. This operates on a fixed block of plain text. The encryption algorithm takes a fixed length block of plain text to create a block of ciphertext in the same length, usually 64-bit, implemented in software. And then the block cipher encryption is slower than Stream. Stream is done in hardware. And then here the examples they provide is DES, triple DES, AES, and IDEA, and you can see here plain text, block cipher, encryption, and then a ciphertext. But if you look at Stream, again, this one's done in hardware, continuous streams of plain text. It's good for serial communications. And then the examples they provide is RC4, CL, and VEST. Again, one's a software implementation, one's a hardware implementation. Now, steganography, this is basically hiding data in another media so that the data is the data is very existent and is concealed. All right, Kat, tell us a little bit more. Take your mic off.
Yeah,
Let's hear
yeah,
from
I
you.
did a CTF a couple years ago where so basically they had a web server that had a cookie, and the cookie was something like a JSON web token, which is like an encrypted bit of text that's like signed by the server. And like the server, because like the server signed it, you can't like change it, right? Theoretically. But so on the server, when you would send a cookie, the cookie's encrypted. This one wasn't actually signed, it was just encrypted with AES, like a symmetric key. So when you'd send the encrypted text, it had like a bit in it that determined if you were like admin or not. And so when you sent the encrypted cookie to the server, if you sent an invalid like encryption, it would like tell you like error or invalid, right? So there's an attack on it where you can just change every bit one by one until it doesn't error. And this is called a padding oracle, because you're figuring out where in the encrypted text it actually had to pad it. Because in AES, if you're under the key size, which is like huge, if your input ciphertext is under the key size, it has to actually put it in there somewhere. So it pads it with like null data, basically. So as soon as you change the data and it doesn't error because the padding like doesn't change, the data changes, you know that that's where the actual like content is. And so if you flipped like one of the bits in there, it would actually like give you admin privileges because it like considered it valid ciphertext.
And Kat, which CTF was this that you learned?
That was Pico CTF.
Was this last year?
2021.
I'm looking. Oh, okay. We ran a Pico CTF this summer, by the way.
Oh, yeah, I did it. I was like in high school then. I haven't done it since. I've just done NCL mostly.
Okay, okay, cool beans. All right, remember, for those, I mentioned that we will have a CTF the 19th. So the information will be coming out, so you can participate in the CTF. I would encourage you to. We'll have like
Which
pizza and some
19th?
other stuff.
October?
Yes, yes, October during Cyber Security Awareness Month.
Okay, cool.
So it's a 24-hour CTF. We'll meet up at like 9:30 in the tower. We'll be together for a couple hours. You'll work in your
That's the
group.
day before NCL. You're just gonna crush me with CTFs.
And then you'll come back that following day, and then we'll have like awards. We'll have like a debrief. It should be pretty cool. Okay, so the cool item that I mentioned was steganography. We'll be doing that, quite a bit of that. And like I said, all this is hiding data in another media. And there's different ways to figure out if that particular media may have something in it. And one of the ways is to check the hash of the original file. So you can check the hash of the original file, compare and say, oh, there's something different here. And then you can also check the properties and look at the file size of the particular item. So you can look at the properties. You can say, I want to look at the properties of a picture. Maybe find an original picture or similar ones like that online. And then you can see, okay, let me see when this was edited, stuff like that. Okay, this one was, previously, but this one it's larger. Does it have something in it? Say, all right, well, maybe this particular media has something that's hidden inside it. So there's different things you can do, but that's kind of like the process of figuring out if that is done. Now, steganography, this is cool because if you're traveling to certain countries where you cannot, maybe have certain types of media, photos or music, you can hide things, you can embed things into each other. We'll do that with a tool as well. You can, place items inside encrypted folders or encrypted containers. And then if you need to share something, yeah, you can just say, hey, here's my file. Go ahead and send it out or send it to me. Just put this tag, and those who understand that tag, oh yeah, this is an encrypted file. I know Bilal sent to that, right? So this is Bilal's file. I know the particular passcode that needs to be put in to actually extract this information. Has anybody here ever done anything as it relates to steganography?
I have.
I have as well, but it was kind of limited.
Okay. What were you doing, Christian?
Just trying it out in high school because, like, I don't remember what it was, but I just found kind of like an article describing it, and I messed around with it a bit, just like with a program that just kind of does everything for you, and then I also somewhat remember something about like working directly within like the hex of an image file or something at one point, but I'm not sure if that was for steganography or if I was just doing something stupid.
So, Chris, do you remember the program? What operating system did you do it on first?
Linux.
Okay. Do you remember the program?
And I have no clue what the program was.
Okay, we're going to use Outguess and StegHide. You have the choice that you're going to use those particular two programs. And
I
then
think it was StegHide.
StegHide is a tool. It's steganography. It's hiding like hide, StegHide. I guess that's the name. I didn't create it. Or I wasn't part of the actual development team at all. But yeah, it's a tool. There's like two open access tools that I use, and those are it: StegHide and Outguess. Fairly easy to install through the terminal. We'll install it. Takes maybe 2 minutes, and it's up and it's ready to run. All right, and Nicholas said only in CTF. So Nicholas, how did you use steganography in CTFs?
Now it's pretty basic. It's pretty much we'd receive some sort of photo, and we were told you have to figure out what is the general message hidden within this photo, which I generally just did with like automatic tools. Honestly, a lot of those were just online websites.
Okay.
Got a couple things I've used. If you wanted me to talk about them.
I mean, unless you're
So-
prepared to become a supervillain, yeah, let's share.
Steg Seek is really interesting because it's like a C program that can crack anything used with Steg Hide. So if you Steg Hide something, like it's fairly trivial to crack like all of the combinations of it within like 2 minutes, at least up to a certain character length, and then you can also throw word lists at it and like do crazy stuff. So like Steg Hide isn't necessarily secure if your password isn't any good. And the way it does that is just by brute forcing them. I've also used a lot for CTF's digital invisible ink toolkit, which is super old and I hate it. But they used a lot. And then I also, there was one time where they actually hid the message like in the image data, like it was actually part of an image, except the way they hid it was by cropping like the specific image format they were using was like you could edit the file header and change what size like the file header defined the image as, and it just basically cropped out the image content. So when you opened it, it looks like a smaller image, and then you'd have to, and the file was like suspiciously large. So I screwed around with it for so long. I was like, none of my tools are working on this. And then eventually I changed the image size to like 1000 by 200. And then it expands and there's this whole other section with a bunch of text written. I'm like, wow, okay.
Well, do you still have the image available? I'm curious how it looks.
It's probably somewhere deep in my files. I will get back to you.
If you find it, please email me. I would love to take a look at that myself. You know, what's funny with steganography, like growing up, like you would always, the people who did steganography, they were always supervillains, right? They're like, we don't know what's going on. There's like secret messages and people are following these messages. And it was, it's because people are, hiding items and image files and stuff like that. And, they say the best way to do something is not get caught is to do it in plain sight, right? So, you're basically doing it in plain sight. You see photos of Siley Myers, you go, oh wow, it's pretty cool, it's interesting from the concert. In reality, there's a whole message there, and it's tagged with take a look at this and some other weird combination of characters, and everybody's sharing the message, passing it out, and only those that is intended for will know what it actually is. So we'll play around with Steg Hide. The one thing I do want to state is when people are cracking items, you're using dictionaries, whether it's English or other languages. If you have passwords based off a dictionary, then you're screwed. You want to make your password complex, right? It needs to be complex, not just email, but anything that you're doing. If you are trying to hide, or keep something secure using characters, make it complicated. But then you get to the point where you probably need a password manager and then a complex password for that. How are you going to manage these passwords? I mean, it gets complicated. You get to the point is like, okay, how do I effectively manage all these unique passwords, right? Then you think about password resets, and it can become a lot. All right. But the strength of your password can make a huge difference. All right, so here it just says a hash function takes an input of an arbitrary length and outputs a fixed size value. And then here it says the maximum number of input and output bits is determined by the design of the hash function. The pre-image resistance, a good hash function is a one-way original input message or file that cannot be derived from the hash value. And collision resistance, two inputs into a hash function should not produce the same hash value. All right, so we're gonna stop here for a moment. And what I want for us to do real quick, I want for us to get some things set up for this Thursday. So I'm going to start a new share. And the new share is going to be Thunderbird. So let's do new share. Because what I want you guys to do is bring up Thunderbird. And I want us to set this environment so we can do a number of things. All right, so this is Thunderbird. You can see here's contacts. This is an email client. And what you're going to do, all right, this is Thunderbird right here, right? So hopefully everybody can see it. This is Thunderbird. And you're going to go to account settings. You're going to go to add email account. And you're going to add an account. And so this is going to allow you to bring in your email. And what you're going to do, you are going to use IMAP, right? You're going to synchronize everything. And use IMAP. You're not going to use POP3. You're going to forward all your emails into here, and you don't want that.
I did actually find the image, so I just emailed it to you.
Oh, awesome. Thank you. Thank you a ton. You're going to sync or here, connect through calendars. Care about birthdays. And it's syncing everything up. And so you can see that it'll probably take like a good 5-10 minutes, but you'll see that is bringing up, whatever meetings I have. So the calendar is brought in here. I think I have quite a bit of messages in here, so it may take a while. But go ahead and get yours started up. And no, Kevin, you don't have to make an account. Use your Hawk account. Use your Hawk account, and it should work with that. Use your Hawk account. And then what it may ask is for you to authorize third-party apps, because Thunderbird is a third-party app, and you will authorize it to access your Hawk account, and then from there you can, everything will be synced. So I have 4:06, so by 4:16 you should have everything available. So I'll give you till 4:16. All right, so it should be I guess pause, but it's resumed now, so you're gonna see mine's is still pushing forward. Yeah, still pushing forward. So it's just mine. It shouldn't have been glitched, just me moving back and forth, that's all. Right, that's it. All right, so once you have this, we're good. And then this will take up a great deal of what we need to do for Thursday. We'll talk about like oh Naeem, I can't hear you. Maybe your mic is Well, your mic is unmuted, but change your.
Oh,
I
oh
can hear
no,
you now.
no, no. I wasn't trying to speak there. That's my bad.
Okay. Oh, well, since you're speaking, what was glitch? Is your screen sharing okay?
It was yeah. I have it now. It was I couldn't see your screen, so that's back now.
Ah, okay. All right, got about 3 more minutes. All right, 2 minutes remaining.
According to my spam folder, somebody has gained access to my account, which isn't even a real email. They're like, we have access to your at my domain email. That one doesn't exist. It's not a real account. It just forwards to my Gmail.
Okay. All right. Hopefully everybody's good. Were there any problems in getting this set up? Anybody encounter any issues or? I think it's relatively easy once you do it once. It's okay. The next thing that we're going to do, since we have some time, and I'll talk about this a bit. So here in settings, you have privacy and security. So here you can see your privacy and security settings. Click on account settings, end-to-end encryption. Have a key already here. I can create a new key. For you, you'll create a key. Continue. You choose the identity. It's the only one I have here. Here, the default is 3 years. The key should never be 3 years. It should 1 year max. And then you can just leave this as is, but there's different key types. Here it just shows 2. The key size shows just 2 as well. But if we change this to elliptic curve, go back to RSA, and then you'll do generate key. So go ahead and generate your key. Go ahead and generate your key. And then once you have, this would take maybe 4 minutes, and once you have that, then we'll talk about kind of this Thursday and the stuff that we'll do. Sure, Kevin. Let's see. I'm sorry, could repeat the steps after entering the end-to-end encryption page. All right, so I went to settings, so account settings, end-to-end encryption. I already had a key, so you can just do open PGP key manager, and then from here you can generate a key, right? Generate a new key pair, and that's what you'll do, and then you'll select the appropriate settings. Or permit, yeah, settings, and just have it like mine is 12:13 to end of the class, and that's what I have it set for. And you can see here that I've already have a student who shared his key with me. No problem.
You're muted, by the way.
All right. So let's talk about what we're going to do this Thursday. So we kind of have a read up. All right, so you go on Blackboard, you look at assignments. Let me actually share that. Share. I'm going to do a new share. All right, so you should see content. All right, so we're going to explore data encryption security tools. You're going to choose either StegHide or Outguess. We're going to go through them both. This is for steganography. And this is the assignment right here. So you're going to also do Veracrypt. Install Veracrypt. We're going to do that together in class. We're going to configure it. We're going to create a container, how to mount, access it. We're going to do email encryption with Thunderbird. Thunderbird's already set up. You'll generate your key. We'll talk about key exchange. We'll demonstrate it. We'll do basic GNU PG encryption. Install GNU PG. The only thing is, like, if we install it, we also have to remove it because for some odd reason it creates issues with Thunderbird. And so we'll do a lot of this stuff together in class, right? And that will be done as a group. So you'll select groups. If you go on a discussion board, there should be something there for already setting up your group. Then you have individual. And individual, it says research and summarize the historical evolution of cryptography from ancient civilization to modern times. highlight historical ciphers and their significance in various contexts. And then here it just says continue assignment instructions. This is assignment instructions, cryptographic protocols. I will post some items that details the protocols a bit more. And then here, define crypto analysis and explain the importance in the field of cryptography. And then discuss the concepts of security and cryptography, including the roles of key length, entropy, and brute force attacks. So I'll make sure I cover this as well, and then I'll send additional resources. So, and we'll talk about that a bit well in class in terms of the actual demonstration. So I'll make sure I cover those and provide you resources. So when you do write the particular paper, you will know how to present this. All right, any questions before you guys have for the rest of the day? Oh, okay, what did I say in network analysis? Oh, I was saying the actual in-class presentation is not going to be a network analysis. I mean, you're going to record everything and you'll have upload it to Drive, no big deal. But for the network penetration, you'll do that live. It'll be recorded as well because not everybody's going to be able to present in class, but some people will be called to present. And then Muhammad says, question, you said once in a class that you might take a group of students kind of tour into the country somewhere. Yeah, so Muhammad, what I'm working on now, I have let me pull it up. IT, Kosovo, study abroad. So there's a page created now. Go to study abroad. All right, so I'm pulling up the page now. And let's see if they have anything. Study away. I don't think it's loaded here yet. Let's see. Okay, it's not on here. I don't see it on here yet. But I'm just waiting on confirmation back from Kosovo CERT, the universities, and the State Department. And once I get that back, hopefully it's by like mid next week, because I can post it. Then you can get scholarships for actually flying up there. There's 2 times to give scholarships, October and March. But I'm just trying to wrap all that stuff up now with the host organization so I can get everything set up. But trust me, when I get the information, I will definitely share it. And I'm also working it that you can do 1 to 2 classes. So for that month, you can get 6 credits and not just 3. All right, any other questions? We have time for one more question.
Hi,
All right,
Professor.
someone did-
I've sent you one email a week back. I haven't heard from you since then.
What was the question?
Like for my temporary absence for a week, like I had to fly away to India.
Yeah, so you'll have to work. Send an email to myself and the TA copy so we can work that on a case-by-case basis. But if it's just because you're late or something like that, then points will be deducted for that.
No, it's not with late assignment.
So let me restate so you can understand it clearly, right?
Yeah.
So if it's excusable, then you will send an email to myself and the TA, right? And you'll state,
I sent you, yeah.
yeah, to listen real quick, to myself and the TA for that, All right, send it to myself
Okay.
and NTA directly addressing that. But I'm saying is like for you, anyone else, if assignments are late or extensions or something like that, there's no extensions for most of the time. Unless it's almost unanimous. But then if it happens to be late, then points get deducted. Now, people, when you send me emails, make sure you have the title of the class in the email. Because I have in one of my classes, I have about 100 students, right? So I get lots of emails that will say, just random subject. I need to know what class that you're referring to. In one of my classes, I have about 100 students. I have, students that I'm advising, so I have many students. In the heading, just state the class. And then you can state, all right, class, and then the reason why you're emailing me. Otherwise, I have to prioritize the students that actually state the class and what you're emailing me about. All right, that is the last question we can take. I will see you guys this Thursday, and we will cover more stuff. And then, this weekend we will be doing tour. We will do tour this weekend. All right.
Professor,
Thank you,
can you
Professor.
clarify about the,
Thank you.
you said regarding the network analysis presentation, is that all of it? Or is it just a specific part?
No, it's all of it. Like let's go through here real quick. I think I have about 5 minutes to spare. Talk about this right here, right?
All
All
right,
right, you're
thank
quiet
you.
on me. Okay, and I'm going through here. I don't tell you to necessarily record anything, because you don't have to record anything, but you do need a presentation that has everything in there. But if you want to record something that goes with a presentation as well, that's perfectly fine. But I'm just looking, I don't say record anything. So yeah, just create a comprehensive presentation that covers all aspects of the assignments, including Wireshark usage, data visualization, Nmap scanning, Maltego transforms, and firewall configuration, screenshots, and clear explanation. And then raw copies of raw data files, screenshots, outputs generated with Wireshark capture, Nmap scanning. Again, you can just, if you're using Nmap, the report's good enough. Nmap, you can just run it to a text file. Maltego transforms, you can have the report in the .mtgl, so it can be open up. Firewall configuration, do the firewall, and then export the configuration. And then label each item separately, appropriately. Fairly explanatory, but if it's nmap.txt or whatever, something like that. Nmap _ results txt. Does that help out?
Yes, thank you.
No worries, no worries. So Pedro, have you started getting everything together?
Yes, me and my group have, I just have to polish up the firewall.
Okay. Aha. Okay. So Kevin, I got your message. Oh, I do want to state something. It's more in particular from my other class. But if you are an international student, you are required to be in class if it's on ground. And that's for ARIA classes. So that's something that's going around. So please expect this message to come from other professors. We have a lot of international students who are not in class. If you are not in class, you can and will be reported to appropriate services. So it's a big issue because as an international student, you're limited to how much online courses you can take per semester, especially if that's the reason for your visa for being here. So international students, please be careful about that. All right, and so Kevin, I will send you a message back specifically.
Yes, Professor.
Yeah, because I believe you are an international student, correct?
Yeah. Yeah. So the thing is that I had a medical emergency. I had to do an emergency root canal, so I had to fly back to India.
Okay. Yeah, we'll have to make sure you have appropriate documentation. So, because this, multiple eyes.
Yeah, like I want to show them the email proof to the immigration officers when I fly back.
Okay. So you need a root canal?
Yes, Professor.
And I suppose it's cheaper back in India than here, right?
Yeah, very much cheaper. Like I can fly to and fro and then just get my root canal done.
Okay. Did you look at Turkey by any chance?
Sorry?
And you pause the recording.